Welcome everyone, I am Ujjwal Pal. Today we will solve a LeetCode problem step by step. The problem number is 1508, which is range sum of sorted subarray sums. Let's see the problem description. You are given the array nums consisting of n positive integers. You computed the sum of all non-empty contiguous subarrays from the array and then sorted them in non-decreasing order, creating a new array of n cross n plus 1 by 2 numbers. Return the sum of numbers from index left to index right, inclusive in the new array. Since the answer can be huge, you have to return it on the modulo of 10 to the 9 plus 7. Okay, let's see the constants. The length will be less than 1000 and each of the element will be between 1 to 100 and left right will be exist. Okay, so you can understand by reading the description. We have to first find all the possible sum, like all the possible sum of contiguous subarray in nums. So first we will find all the sums that could possible. Okay. Second, uh, we have to sort it in non-decreasing order, or you can say increasing order. Then we have to find the sum from left to right, both are inclusive index, and then we have to return it by modulo of 10 to the 9 plus 7. Okay, this is the main task. So you can use a array like an array to first store all the sums, then you can sort the array, and then you just take the sums from index left to index right and then return it. You can do that, or otherwise you can also use priority queue. Max priority or min priority queue doesn't matter. So I will say, like, let's say you take the min priority queue. So the top element will be the minimum. So first insert all the sums could possible in nums in the priority queue, and then pop, like, first left minus one element, like left is the starting will be left, so before left how many elements are there, you have to pop them out, then calculate the sum from left to up to right, and then just return the sum by modulo of this. Okay, so I will show you both of the algorithm. First I will show you how can you do that by using an array. Okay, so first we will create an array vector and receive. So for int I equal to 0, I less than nums dot size I plus plus, and in sum equal to initially 0, and for int j equal to I, j less than nums dot size and j plus plus. First we will calculate the sum plus equal to nums of j. Okay, and you have to put it in the VC like vector dot push back the sum. Okay, now we got all the sums that could be possible, like with the element present in nums. Okay, so after that we have to sort them out. To sort, vc dot begin, vc dot end. So after sorting, you calculate the answer equal to initially 0, int mod value initially it is 10 to the power 9, you can say 109 plus 7. Okay, now that calculate from index, the left and right are here is index from 1. Like if the left is 1, for example this here left is 1, that means we have to calculate from index 0 and to up to index 4. Okay, you can see like the answer is 13, that means this is the sorted array. So 1 to 5 means first 5 elements. Okay, so first 5 elements means index 0 to index 4. Okay, so we will traverse from I equal to left minus 1 and up to I less than right, then I plus plus. First calculate answer plus equal to the VC of I, then you have to mod it. Answer mod equal to mod. Okay, then you just return the answer. Okay, let's see, will it work? Let's submit it. It is accepted. Let me discuss the time and space complexities with you. So the time complexity will be, you are storing all possible sum that could possible by presenting elements of num. You are traversing, you are calculating for all the elements. So time complexity for this nested for loop will be big of n square. First for loop is running n times, and for each of the element, a second for loop is also running from I to less than n. So you can say the overall time complexity of for this nested loop is big of n square. To sort them out, this sort function takes big of n log n time, but here n is like n square because size of VC is n square already. So you can say the sort function will take like n square log n square. Okay, and for this for loop, it is like the length of right minus left, you can say. So the overall time complexity will be n square log n, you can say, or n square log n square actually, for this sorting function. And the space complexity, we are storing all the possible sums in the vector. So the space complexity will be same as this, n into n plus 1 by 2. Okay. So the next algorithm, we will use a mean priority queue. Okay. The top element will be the minimum one. So we will store all the sums in the mean priority queue. Then we will pop the first left minus one element. Then from left number left to right, we will calculate the all sums. Then we will return it. Okay. Let's see how we can do that. So first we will create a mean priority queue int vector int greater than, let's say TQ. This is how you create a like mean priority queue, and this code will be the same. Just change this one, like push TQ dot push the sum in the mean priority queue, and we don't need this, but we need the mod equal to 1e9 plus 7. The answer initially is 0, and the current value, like current index, which is, let's say int is 1. Why 1? Because the left and right are already increased by 1. So I will just, instead of 0, I am taking starting from 1. So we will check while index is less equal to right. Okay. First we check if index is greater equal to left or not. If it is greater equal to left, then we need to add it in the answer. So answer plus equal to pq dot top, and then you need to mod it also. So mod equal to mod, and otherwise you have to pop it out, pq dot pop. That's it. And also you need to increase the index by 1. Okay, and after the while loop you can just return the answer. Let's see, will it work? It is accepted. Let's submit it. It is also accepted. So let me discuss the time and space complexity of this algorithm. So the time complexity will be the same, because for each of the element, like for it, this nested for loop will take big of n square, and to push one element in the priority queue, it take log n time, but here the n will be the like n square. So you can say for this nested loop, the overall time complexity will be go n square log n square. Okay. And for this while loop, it is same as like up to right. So you can say big of right. This will be the time complexity for this while loop. So the overall time complexity for the whole code will be n square log n square, same as the previous. And the space complexity will be also the same because we are storing all the sums could like that could be possible using the elements of nums. So storing all that sums in the min priority queue. So the overall space complexity will be same as n into n plus 1 by 2. So thanks for watching. If you want to check out the code, you will find it in the description box below. So that's it for today. See you in the next video.